Just a quick note before we move on to the next example. Horizontal asymptotes are allowed to be crossed. We saw that in the previous example. It just helps us describe in behavior. So that middle section in that previous example, the function crossed over the horizontal asymptote, but it did help us determine the in behavior. Where was the function approaching towards negative infinity in the x's and towards positive infinity on the x's. But a horizontal asymptote can be crossed. A vertical asymptote cannot be crossed. Okay, so for this next example, we're going to do the same process. So we are going to follow the same process for our next problem. We are going to first look for vertical asymptotes. Remember, in order to do that, we take the denominator and we set it equal to 0. When I solve this, I'll get x squared is equal to positive 4. That's good. Then I take the square root of both sides, and I get that x is equal to positive or negative square root of 4, which is equal to positive or negative 2. Okay, so we get our two vertical asymptotes in this problem. Sometimes you'll have one, sometimes you can have a lot more than that, but this time we have two. It's at x equals 2 and x equals negative 2. So that's for our vertical asymptotes. For our horizontal asymptote, we look at the degrees of the numerator and the denominator of the rational function. They are the same because both of them have a degree of 2. So when their degrees are the same, we get y equals the leading coefficient of the numerator over the leading coefficient of the denominator. So we get that the horizontal asymptote is equal to y equals 2. Okay, so there we go for that. Next, we are going to figure out our x-intercepts. In order to do that, we take our numerator and set it equal to 0. This will only be equal to 0. If I divide both sides by 2, I still get x squared equals 0. So x is equal to the square root of 0, which is just 0. So our x-intercept is 0. Okay, that also is going to mean something about our y-intercept, but I'll make sure that we see that and how that happens. For our y-intercept, we find, let me make that a colon, we find f of 0, which is going to be 2 times 0 squared over 0 squared minus 4, which is going to be 0 over negative 4, which is just 0. So our x-intercept and y-intercept are at the origin. Okay, so we didn't get as many extra points on this one, so we're actually going to have to do kind of a lot of picking points in order to figure that out. Here we go. All right, so I've already put in the vertical asymptotes at x equals negative 2 and x equals positive 2. I also put in the horizontal asymptote in purple. That is my y equals 2. And now I'm going to plot my x and y intercept, which was just the origin. So we get this is my x and y intercept. So here's what's going to have to happen. I'm going to need to pick some values. I'm probably going to want to do, let's do like f of negative 10, f of negative 3, okay. Over here I'm going to do f of 3 and f of 10, get those values, again by substituting that into the original function and finding out what is the function's value at those points. So when I substitute in negative 10 for all the x's, what do I get, etc. And then for this section, I'm going to do f of 1 and f of negative 1. We're going to find out all of those. Again, I'm going to pause, use my scientific calculator to get those so you don't have to see me calculating them. Okay, so we're going to see some nice symmetry within this rational function. So I'm going to do this middle section first. When I do f of 1 and f of negative 1, I get the same value. I get negative 2/3. So if I look there, this would be right here, and this would be right here, those two green dots that I just plotted. Okay, so then in that middle section, it looks like we're going to have kind of a skinny, almost parabola that goes underneath that, or in between those two vertical asymptotes, which we'll draw in at the end. So then for the other sections to the left of x equals 2 asymptote, or negative 2x, the x equals negative 2 asymptote, we're going to look at to the left, and to the right of the x equals positive 2 asymptote, we're going to plot these points. And if you look, there's some beautiful symmetry. F of negative 10 is 2.08, f of positive 10 is 2.08. I hope you realize it's because the function just has the x values being squared, which gets rid of the negatives. So let me plot those points. F of negative 10, so that's 2, 3, 4, 5, 6, 7, 8, 9, 10, and that's 2 point, just a little bit over 2. Notice how close that is to that horizontal asymptote. And then f of negative 3 is at 3.6. 3.6, that's approximately right there. Same thing over here. Okay, 3, 4, 5, 6, 7, 8, 9, 10. A little bit above 2. It is so hard to draw this. Okay, so now I have my points, and now I can draw my function. So what color do I want to pick? Let's do brown. Okay, so I'm going to do the middle section, connect that x and y intercept to these points. Now remember, I do not like how I drew that. Remember, third time's a charm, let's hope. Okay, so we're going to draw that. Remember, it gets close to the asymptote but never touches. And same thing on that side. Lovely. From here, this is going to approach this vertical asymptote and then come down. And this is essentially a mirror image of that one. Nice. Okay, so that is our second example. Okay, the last part of section 3.5 discusses slant asymptotes. A slant asymptote happens in a rational function if the degree of the numerator is exactly 1 greater than the degree of the denominator. So if your degree in the numerator is 3 and the degree in the denominator is a 2, then you're going to have a slant asymptote. If the degree of your numerator is a 2 and the degree of your denominator is a 1, you will have a slant asymptote. Okay, so to find the equation of a slant asymptote, we divide the numerator of the function by the denominator using either long division or synthetic division. The slant asymptote will be in the form y equals whatever your quotient is. So we're going to use something that we did in 3.3 in order to do this problem. So we're going to determine the slant asymptote of this rational function. Okay, the function is f of x equals x to the second power plus 5x minus 5 over x plus 1. So to find the slant asymptote, we're going to divide the numerator by the denominator using synthetic division. Remember that this is x minus c, so since this is a plus 1, what's on the outside is going to be a negative 1. Then I take the coefficients of the numerator, and I'm going to synthetic divide. Okay, so remember, this is your remainder right here. So what we are focusing on this quotient is this quotient, and this quotient represents x plus 4. So this is my slant asymptote, y equals x plus 4. So that means that this function, this rational function, will have a slant asymptote that it gets really close to and follows for in behavior, that is that linear equation. Y equals x plus 4. Please make sure when it asks you for the equation of the asymptotes that you include the y equals. For a slant asymptote, you need a y equals for any horizontal asymptotes, or you need x equals for any vertical asymptotes. You'll need that for your homework. Okay, so the last part of this is kind of putting all of this together to graph something that has multiple aspects to it going on. So we have this function, f of x equals 2x squared minus 8x plus 8 all over x minus 3. And what we're going to do is we're going to look for vertical asymptotes first. So we take this, actually, before I even do that, I'm going to take the numerator and I'm going to factor it out. I'm going to factor out a 2, and then what will remain will be x squared minus 4x plus 4 all over x minus 3. And then I can factor out that and get 2x minus 2 x minus 2 all over x minus 3. And the most proper way to write that would be 2 times x minus 2 squared over x minus 3. Okay, so first factor out anything that you possibly can. That will make this process a lot easier. Second thing you want to do, also you want to do that before you check for vertical asymptotes, because remember, if x minus 3 could cancel with any of the numerator's factors, then we wouldn't have an asymptote, we would just have a hole. So you always want to double check that and make sure that if the numerator is a quadratic or can be factored out by any way, that you factor it and see if anything cancels. So for the vertical asymptote, we take the denominator x minus 3 and we set that equal to 0. So the equation of the vertical asymptote is x equals 3. Okay, then we find our horizontal asymptote. But look, remember from earlier, if the degree at the top is greater than the degree of the bottom, then there is no horizontal asymptote. So the degree on top is greater than degree on the bottom. Therefore, there is no horizontal asymptote. Okay, then from here, we can say, okay, let's look for a slant asymptote. Okay, a slant asymptote occurs when the degree of the numerator is 1 greater than the degree of the denominator. That is literally one of your homework questions. Please make sure you get that right. So our degree of our numerator is 2 and the degree of the denominator is 1. So therefore, we have a slant asymptote. To find that, I'm going to do some synthetic division. So my x minus c is x minus 3. That's what I'm dividing by. So I end up having a 3 on the outside and 2, negative 8, positive 8. Bring this down. I get 2. 3 times 2 is 6. Negative 8 times, or plus 6 is negative 2. 3 times negative 2 is negative 6. And 8 minus 6 is 2. Okay, so that is our remainder. And remember, what we want to focus on is this, and that represents our slant asymptote is equal to y equals 2x minus 2. From there, we can look for our x-intercepts and our y-intercepts. So I'm going to first start with x-intercepts. And the x-intercept is when the numerator is set equal to 0. Remember, I factored that in the beginning, so I can just take 2x minus 2 squared equals 0 and solve that. So I'm going to divide both sides by 2, which just gives me x minus 2 squared equals 0. Nice. Take the square root of both sides, which just gives me x minus 2 equals 0. Okay, because the square root of 0 is the square root is just 0. And so I get that my x-intercept is equal to x equals 2. Now, one thing to note about that is that this 0, this x-intercept, actually has a multiplicity of 2. So remember, that means that this is a touch point, not a cross point. Okay? So you can tell that because here we have that squared, or you can see that the factor x minus 2 shows up 2 times. All right, so for the y-intercept, running out of colors. I know I'm running out of space too. The y-intercept, we're going to find f of 0. So just plug 0 into the function. I'm going to trust that you guys can do that. If you can't, send me a message or meet me in Blackboard Collaborate and we'll work that out. But we get f of 0 equals negative 8/3, which is the same thing as negative 2 2/3. So that's the information that we need initially to graph this function. So let's start graphing it. We had our vertical asymptote was purple, so I'm going to put that in purple, and that was at x equals 3, so I'm going to draw that in right here. Okay, we have a slant asymptote. So we had no horizontal asymptote, but we did have a slant asymptote. So I'm going to graph that. Now remember, I can graph that slant asymptote. It's y equals 2x minus 2 by starting at the y-intercept, negative 2, and going up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And I'm going to graph this as a dotted line. Okay, so that's my slant asymptote. Now, I do know my x-intercept. Sorry, I got lost in all my colors. My x-intercept was blue. Oops, I switched that around. My x-intercept was at x equals 2, and it has a multiplicity of 2, so it is a touch point. My y-intercept was at negative 2 2/3, so that's around right here-ish. Okay, and so actually I can already see that this is going to look like this. Now all I need, because I've done my y-intercept, I've done my x-intercept, all I need are points within this section. Let me circle this section right here. So I'm going to check f of 4 and f of 5. Okay, so when I substituted 4 into the function, I got that f of 4 is going to be equal to 8, which is right here. Boop, right there. And then f of 5 is equal to 9, which is right here. So again, we're going to get some sense of this happening up there. So we have, this is our function. We've graphed our asymptotes. We plotted our points that we needed to plot. We followed our in behavior. This is perfect.